Okay, now on number 2, we're going to graph y equals cosine of x. So again, I've taken the chart, I have values plugged in for x that we're going to use, and we're going to calculate the cosine of those values to get our y value. So again, you can look at your unit circle for these values. The cosine of 0 is 1. The cosine of pi over 4, again, square root of 2 over 2, but in decimal form, 0.7. Cosine of pi over 2 is 0. And cosine of 3 pi over 4 is negative 0.7. Cosine of pi is negative 1. Cosine of 5 pi over 4 is negative 0.7. Cosine of 3 pi over 2 is 0. Cosine of 7 pi over 4, 0.7. Cosine of 2 pi is 1. Okay, so now I'm going to plot those points on the graph that I have, and notice this time my first point, when x is 0, my y value is 1. Okay, so that's a big difference. And how you can identify the difference between cosine and sine is that we have a point 0, 1, whereas for the sine function we had the point 0, 0. Okay, then pi over 4, 0.7. Pi over 3, or pi over 2 is 0, the y value. 3 pi over 4, negative 0.7. Pi is negative 1. 5 pi over 4, negative 0.7. 3 pi over 2, 0. 7 pi over 4, 0.7. And then 2 pi at 1. Okay, and here we have our sine curve, or cosine, I'm sorry, I said that wrong. This is the graph of y equals the cosine of x. Okay, this is one portion or one period of this graph from 0 to 2 pi. Okay, if we were to add on extra points, we could tell from our pattern here what's going to happen. At negative pi over 4, my y value would be 0.7. And at pi over 2 would be 0. So we would see this curve again. Okay, it would continue just like sine, but how we can tell the difference is look at the characteristics here at the origin. Remember, our point here at 0 is the y value is 1. Okay, that y value is always going to be the same as your amplitude of your function. So here my amplitude is 1. Period is still 2 pi, because if we continued past 2 pi here, we would have a repetition, so this would be one period of our cosine wave. The domain, negative infinity to positive infinity, just like the sine, and range, my y values are still staying between negative 1 and positive 1. Okay, flip over to the back and we'll look at some more characteristics of how we can find amplitude and period by looking at the equation. Okay, so amplitude, period, and phase shift. If we have the graphs of y equals a sine of bx plus c and y equals a cosine of bx plus c, where b is greater than 0, we will have the following characteristics. The amplitude will be the absolute value of a. Okay, so think about my equations I had on the front. Y equals the sine of x. Well, my a value is the understood 1. That is why my amplitude was 1 there. The period will always be 2 pi divided by b. Okay, well again in this equation my b value is the coefficient of x. It is an understood 1, so 2 pi over 1 is the reason why our period here was 2 pi. The phase shift is, if you think about transformations we talked about in the first chapter, the phase shift is whether this graph is shifted left or right. Okay, the horizontal shift of the graph is negative c over b. So here in the equations we had on the front, there was no phase shift. But for some of the equations that you see, there will be. And then it says if a is less than 0, the graphs will be reflected about the x-axis. Okay, so that means if we have a negative coefficient here, then our graph will be a reflection, but the amplitude is still the absolute value, still the positive value there. Okay, if I look at the example here, we can see where in the dotted graph we have the graph of y equals sine of x, but the solid graph has a phase shift of pi over 3 units to the right. So we can see where this dotted line has just been shifted to the right, pi over 3 units. So that's an example of a horizontal shift to the right. Okay, if we look at the other one here with cosine, notice my A is 3, so that means my amplitude is 3. We see that's where our point here, our highest y value is 3. Okay, and the lowest is -3. And then I have a phase shift to the left of pi over 4 units. So again, the dotted line is y equals 3 cosine of x, and the solid line is that graph shifted to the left pi over 4 units.